All right, so prior to this point, we had only considered one good, right? We were only considering beers, or we were only considering, I guess this whole lecture has been beers. What does that say? But we were only considering beers, and we are paying for it with money. And, in the beginning, I gave the example of bananas. But let's formally introduce a way of comparing different goods. So what the utility is across multiple goods. So it doesn't have to be the case that you're only consuming beers or whatever. Typically, people consume many goods, right? I mean, when I go out to eat, I'm not just drinking one drink, and I'm not just eating one thing. Usually I'm getting a couple things. So what is my utility for, this meal with this side versus this meal with this side? Well, we can represent goods in what are called consumption bundles, and each consumption bundle comes with an underlying utility. So a consumption bundle is the basically the basket of goods that you consume. So if you go to a meal, you can represent that as one meal, and that's like a one-dimensional good, right? Just one thing. Or you could represent it in multiple dimensions. You can say, I ate 6 mozzarella sticks and 3 slices of pizza and 2 chicken fingers and a large diet soda, and then I ate a bunch of ice cream, right? That would be a consumption bundle of multiple things, each with their own individual utility, but as a whole, you can represent the bundle as having a total utility as well, okay? So consumption bundle is just a bundle of a bunch of things that you consume, okay? And you can represent them as an n+1 dimensional utility function, okay? So U sub x could be your consumption bundle, where U sub x is your utility from the consumption bundle. So what does any of this word mean? This is all complicated, right? This is all just George's mumbo jumbo. So imagine you had one good, okay, and it gave you x utility, or it gave you 5 utility. Okay, x is a bad example. So you have one good x, and it gives you 5 utility. Okay, that's going to be a 2-dimensional function, right? You're going to have your, where'd it go? You're going to have your x is your consumption, and your function u of x, right? That's a u. So your function u of x, right? And it could be, diminishing marginal returns or whatever. So if x is your consumption, and it's one good, your u of x is going to be the second dimension. So this is a 2-dimensional graph, right? 2D, okay? 2 dimensions. But it doesn't have to be so. You can have a 3-dimensional graph. Let's say soda, mozzarella sticks, and then this is your utility. And the more mozz sticks you have, the higher utility. The more soda you have, the higher utility. The more mozz sticks and soda you have, I don't really know how to draw it 3-dimensional, off the top, but it'd be like even further. So, but basically, it'd be like a bowl shape of, concave, like a curved bowl, like half of a bowl of different utilities for different combinations of mozzarella sticks and soda gives you different utilities. But this is a 3-dimensional graph with 2 goods, 3D, 2 goods. So what's the third dimension? The third dimension is your utility. Okay, so that's what I mean when I say representing n goods as n+1 dimensional utility function. If you have one good, it's going to be the goods, the amount of that good you consume, and the utility you get from consuming that good. If you have 2 goods, it'll be 3 dimensions. the amount for the first good, the amount of the second good, and the utility you get from that consumption bundle of mod sticks and beer, or mod sticks and soda, or whatever it was. Okay. So you can represent your consumption bundle as an n+1 dimensional utility function. But that's like terribly hard to do. You saw me struggle to draw this graph, and this looks like nonsense, right? This is complete. I mean, like, you can find better visual representations of multiple dimensional items. You can really only get to the third dimension without like having some sort of complex GIF or something like that. But what do you call it? We typically want to have a much easier way of representing your utility over two goods as a two-dimensional function, because 2 dimensions is kind of where it's at. Okay, and this is just kind of something we do just to simplify things, but you're not actually, like, when I say simplify things, I just mean simplify the visual representation. You're not actually making any assumptions, any additional assumptions or anything, but you can boil a three-dimensional graph into a two-dimensional graph using what's called a contour map. And basically what that's saying is, like, everything on this line represents a combination of mod sticks and sodas that give you utility 2. Everything on this line represents a combination of mod sticks and soda that give you utility 1. Everything on this line represents a combination of mod sticks and soda that give you utility of 3. So you might have a point. Oh, where'd it go? So let's say 2 mod sticks, 3 sodas. Over here. Okay. You might have a point. So 3 mod sticks, 2 sodas over here. Okay. But by virtue of being on this line here, you know that they had the same utility. Okay. So 3 mod sticks and 2 sodas gives you the same utility as 2 mod sticks and 3 sodas. And that the numbers are arbitrary. Just know that anything on this green line gives you utility 1. Okay. You might also have 4 mod sticks, 2 sodas, and the extra mod stick gives you an extra thing of utility. So that might be on this line here. Okay, actually it should be directly above because, wait, sorry. I want it the other way. I want 3 mod sticks, 3 sodas up here, and the reason why I'm doing that is just because this is the amount of soda that you're drinking, so it should be directly above the other point. So like these points should be directly above, one should be directly below the other, and the other should be directly above the other. Okay, so 3 mod sticks, 3 sodas gives you a utility of 2, so that extra soda gave you a utility of 1. You could say that the marginal utility of that third soda is 1. This is another way of saying it. Okay. And then you could have another point that gives you a utility of 2, so it's going to be on this red line. That will be, let's say, 2.5 mod sticks and 3.2 sodas. Okay. And that could be like this point right here. Oh, I want it blue. That could be like this point right here. Okay. And then you can have more mod sticks and some combination of mod sticks and soda. That'll get you at higher points. Okay. But, so we call this contour map, this way of representing fixed utilities utility of 3, utility of 2, utility of 1, as a function, like flattening the utility and then plotting them like this. It's just a way of flattening a three-dimensional visual representation to two dimensionals. We call that indifference curves. And it's called indifference curves because on all points on this green line, you are indifferent between every bundle. You are indifferent between 2 mod sticks and 3 sodas, or 3 mod sticks and 2 sodas. Okay. On this red line, you are indifferent between 2.5 mod sticks, 3.2 sodas, and 3 mod sticks, 3 sodas. Okay. So everything on the red line you're indifferent about. Everything on the green line you're indifferent about. Okay. Regardless of what consumption bundle you're paired with, as long as it lies on the green line, you know that it will give you the same utility. Okay. So as long as it lies on the same line, it gives you the same utility. That's why we call it an indifference curve. You're indifferent between this bundle and this bundle, or this bundle and this bundle. Okay. Are we indifferent between this bundle and this bundle? Well, hell no, right? This bundle gives you a higher utility than this bundle. So being on the line means you're indifferent. Being on a higher line means that you're not indifferent, right? You get a higher utility. Okay. So indifference curves flatten the utility function between 2 or more goods so that it represents all the consumption bundles that yield a fixed utility. It's a contour map. It's another way of saying that. Okay. So let's say that Abby likes both beer and samosas. Consuming 4 beers and 1 samosa leads to a utility of 5. 10 beers and half a samosa also leads to a utility of 5. So which consumption bundle would you rather pick, 4 and 1 or 10 and half? You're indifferent. You're indifferent. They both yield the same utility. Okay. What about 8 samosas, 1 beer? Also indifferent. Okay, so if we plot them all in the same function, we get the same utility. So these consumption bundles lead to the same utility, so they lie on the same indifference curve. Okay. We can do this for the same utility levels, or we can do the same for different utility levels, right? So we can have higher utilities for more beer or more samosas. Okay. So as you increase your samosa count, holding fixed beers, presumably if you like beers, you're going to have a higher utility. Okay, so going rightward is going to lead to a higher utility as long as you like samosas. Going up is going to lead to a higher utility as long as you like beer. Okay, so the further away from the axis you go, the further northeast you go, the higher your utility as long as you like both goods. Okay. If you don't like both goods, then that doesn't hold. Like if it's beer on the y-axis and pollution on the x-axis, well, you'd expect the less pollution, the better. So you'd want to go northwest. You'd want to consume more beer and less pollution. Okay, but for the purpose of this class, I'm only going to give you goods that you like, because that's standard. Why would you even consider an economic problem where you're trying to maximize a variable and you know that one variable you don't like at all? Well, you're going to set that variable equal to 0, obviously, right? So I'm only going to give you goods that you both like, or 2 goods that you like. And I'm only going to give you 2 goods for simplicity, but it doesn't have to be that case. You could have millions of goods. And in graduate level economics, you typically would you usually just represent them in different fashions. Okay. So some notes on indifference curves. So indifference curves are downward sloping, right? And when I mean slope, I'm thinking of what I was saying earlier, where if I were to draw a tangent line, a line that touches only at this point, the slope is going to be negative. If I were to draw a tangent line, a line that only hits at this point, the slope is going to be negative. A tangent line from this point is going to be negative. Why is it negative? Because there's some sort of trade-off, right? In order to be indifferent between a bundle, if you like both goods, presumably you're going to have to consume less of one good, more of another good, right? So like if I had 0.510, right? And I wanted to be indifferent between 0.5, 10, and some other consumption bundle, I'd either have to consume more beer and less samosas, or more samosas and less beer. But if I'm consuming more of both of them, I should expect to have a higher utility. Okay, so indifference curves are going to be downward sloping because it demonstrates there's a trade-off where if you want to be at the same utility level, you're going to have to increase one good, decrease another good. Okay. Like I said before, the further away from the axis you are, the more utility you should have, as long as you like both goods, because the further away from the axis, the more of both goods you're getting. Okay. Preferences are convex, and by that I mean they're shaped, instead of being shaped like this, where it's like a straight negative slope, they're shaped like this typically. Typically, not always, but typically. And the reason is because you prefer, in general, or most people will tend to prefer mixtures. So you'll prefer, let's say, if you consumed an extreme amount of beer and a very minimal amount of samosas at point A, or an extreme amount of samosas and a minimal amount of beer at point B, if we took some mixture between the two, it's going to be on a higher utility curve. I'm actually going to redraw this with different colors because this is not very helpful. So let me reiterate that point. Okay, so let's get my axis. And it doesn't matter if you have beer or samosas on the axis, except in, like, it's just like the PPF. I'm going to tell you which one I want on what axis. Geez, Louise. So let's say beer, samosas, right? Is that what I have before? No, I have it the other way around. So let me be consistent with the other graph, but it doesn't matter. It's not economic theory that you have to have samosas on the y at all points. Okay. All right. So if I have some bundle, let's say 10 beers, one samosa, 10 beers, and that utility equals 5. So that's going to be way up here, right? One samosa, 10 beers. And if I have, let's say 2 samosas, just for my own sanity, it's just easier to think about. And let's say I have let's say I have 12 samosas, and I just wanted an even number. 12 samosas, 4 beers over here, and the utility of that was 5. Okay. So the 2 samosas, 10 beers is going to be over here. Okay. And 12 samosas, 4 beers is going to be somewhere like here. Okay. And what's like the average bundle? So like somewhere in between some mix of these two consumption bundles. So the average between 2 and 12 is 7 samosas, and the average between 10 and 4 is 7 beers. So that kind of worked out nicely. What's the utility for that? Well, we don't know. But if we were to draw a line, well, I don't know why it's doing that. But 7 samosas, 7 beers should be somewhere directly in between this line. Okay. And this line is just going to be a line of mixtures between beers and samosas. Okay. But if I was to draw a utility function, an indifference curve, right? It's going to cut through these 2 points, right? But as long as the utility function has convex preferences, this is going to be on a higher indifference curve. Okay. So u equals 5 over here. And then I can say, as long as I like both beer and samosas, that u is greater than 5. Okay? So by virtue of having an indifference curve that's shaped like this, what that's saying is if I were to draw a straight line in between them, the mixture would be at a higher utility curve, or a higher indifference curve, or would have a higher utility. And in words like logically, what does that mean? It means that I would rather eat some mixture between I would rather eat some moderate amount of beers, or drink some moderate amount of beers, eat some moderate amount of samosas, than I would drink an insane amount of beers and not eat anything, or eat an insane amount of samosas and not drink anything. I'd rather have something in between. My utility for the mixture is higher than my utility for the extremes. That's all that shape is basically saying. So typically economists will build in utility functions that give you this shape, and diminishing marginal utilities kind of plays into that. But there's nothing magical about that shape. It is, at the end of the day, an assumption that you like the mixture more than you like an extreme amount of things. It's not always going to be the case, but economists will typically assume that. All right. All right, so the last point I want to make, and I think I'm going to wrap up after this, is that you should never cross your utility curves, or indifference curves. I keep saying utility curves. Never cross your indifference curves. Why not? Okay, so imagine we had another set of utility curve, indifference, geez Louise, another set of indifference curves, okay, and they crossed. Okay, well, this represents some fixed utility, and this represents some utility, right? What's the utility for this consumption bundle? Hell if I know, it doesn't make any sense. How can you have two utilities for the same consumption bundle? That would mean that you have irrational preferences that will change based on context, which economists don't like. It doesn't make any sense. It's very difficult to work with that because you will have inconsistent answers when you build your model. So you never want to cross your utility indifference curves, because otherwise you're going to have consumption bundles that have unclear utility levels. Okay? And just to remember that, I have the Ghostbusters. Remember, Ghostbusters have this quote, "Don't cross streams, never cross streams," because then leads to, I forget it. It's been a while since I watched Ghostbusters, actually. This is a dated reference even for me. But don't ever cross your utility function or your indifference curves, because that means you're going to have a consumption bundle with two utilities, which doesn't make any sense because your utility should be stable across consumption bundles. All right, I'm going to stop there. That'll be it for this week, and then we'll pick up with marginal rate of substitution and the substitution and income effects next week. All right. I hope everybody got the election results that you wanted. I'm clearly not watching right now. I was checking in between videos, so I don't know who that is, who's winning right now, and it's bugging the crap out of me. But regardless of who's winning, I hope it's the person that you want. Yeah, that's all I say. Have a good week. If you have any questions about the quantitative assignment 3, please show up to office hours tomorrow, 8 p.m. to 8:45. As always on Wednesdays, which is tomorrow for me. So, yeah. And if you just want to chat about economics, feel free to come to the office hours, or if you have a question about your grades or whatever, that's what I'm here for. I'm here to answer your questions. And the more people show up to office hours, the better use of both of our times, I think. All right. Have a good day. Bye.